Provided all of you provided all of you agree, okay, to drive by to use public transport to go from here to the to Fort, I have all the incentive to take my own car because I'm going to find roads which are empty. Right? I'm going to have good fun driving in nice pollution-free air. Right? So I'm going to get a nice drive to Churchgate, and therefore actually nobody will actually believe in these commitments, and therefore there will be too much driving. Right? You see how important this idea is. Okay, lots of issues that we think of in society can actually be understood as examples of prisoner's dilemma. So the second review question for you is, what is prisoner's dilemma? Okay, and think of examples of the prisoner's dilemma from your day-to-day life. Okay, think of examples of prisoner's dilemma from your day-to-day life. So how do you solve games of this kind? You see who the players are. You see what are the actions available. You see what are the payoffs. You think what are the utilities. Right? You create preference orderings, assign utilities, create the matrix, right? Create the, which is called the normal form game. And in that normal form game, look for dominant strategies. Look for dominant strategies and solve for the dominant strategy equilibrium. Okay? That's how you solve such games. Is this idea clear to everybody? So we have a dominant strategy equilibrium and sure? Okay. Unfortunately, not all games have dominant strategies. Some games may not have any dominant strategies. I'll give an example. Okay? Think of a couple, a husband and a wife, who both work, who are both busy professionals, who are planning to do what to planning on a nice weekend evening. Right? Now the wife actually is a boxing fan. Right? Whereas the husband likes operas, musical operas. So the husband would much rather go and watch a musical opera. The wife would much rather go and see a boxing match. But whatever they do, they would like to do it together because they want to spend an evening together. Right? Okay? So let me write the husband's preferences. Okay? O stands for opera, B stands for boxing. Okay? Right. So what do you think the husband would prefer? Opera? But he goes to the opera and he also takes the wife along to the opera because he wants to be with his wife. Right? So the husband's most preferred relation outcome will be OO. What will be his next best preferred outcome? Boxing, right? Because if he has to go out and watch a boxing match, then he will do it if his wife wants to do it. So, what will be the next best? The husband watches opera and the wife watches boxing. Each one does what they want. Right? And the final will be the husband goes to boxing and the wife goes to opera. Sure? I can again assign some utilities to it. What would be the wife's preference ordering?
Boxing.
Both of them would like to go for boxing. At least as good as?
Opera.
At least as good as?
Boxing opera.
Boxing opera? Yeah, wife? No.
Yes. Boxing opera.
See, this refers to what the husband does. This refers to what the wife does.
Right.
Right? Yeah, you're right. It should be BO. This refers to what the husband does, this refers to what the wife does.
No, sir.
No. See, this it is actually right. Yeah? Because this is what the husband does, this is what the wife does.
Right.
Now, in this case, what is the husband doing? He's going to the opera. This is what the wife is doing, wife is going for a boxing match. That's what she wants to do, and this is what he wants to do. This is a case where the husband is going for the boxing and the wife is going for the opera.
But shouldn't the wife choose dominant to be the boxing match?
No. See, so clearly, the wife wants to see here. The wife chooses. The wife's most preferred outcome is both go for boxing. That the husband goes for boxing, wife goes for boxing. The second best is opera, and according. Right? 4, 3, 2, 1.
That means both cases first coordinator shows husband and second coordinator shows
Always. And whatever I do, the first coordinate gives you what the husband does. The second coordinate gives you what the wife does. Right? Okay. So now let me write this as a game. Okay? Let me write this as a normal form game. So I'll write this here because I want to compare this. Okay? Husband, wife. Boxing, opera. Boxing, opera. Now if the husband goes for the boxing and the wife goes for the boxing, what does the husband get? No. If the husband goes for the boxing and the wife goes for the boxing, so it's BB, right? It's BB. So the husband gets 3 and the wife gets 4. Right? If the husband goes for the boxing and the wife goes for the opera, husband goes, so it's BO. BO, husband gets 1. And what does the wife get? 1. Right? If the husband goes for the opera and the wife goes for the boxing, so it's OB. 2. And if both of them go for the opera? If both of them go for the opera, 4. Now here, contrast the two games. In this case, C was the dominant strategy. Right? Why? Because P1 was better off choosing C irrespective of whatever P2 chose. Sure? So 2, because his payoff for 2 or 4 as against 1 or 3 from choosing NC. Can you identify a dominant strategy like this? Is B, for example, a dominant strategy for the husband? If he chooses B, he gets either 3 if the wife chooses B or 1 if the wife chooses O. If he chooses O, he gets 2 if the wife chooses B or 4 if the wife chooses O. So he is better off choosing B only if the wife chooses B. But he is better off choosing O if the wife chooses O. So there isn't an obvious, unambiguously better way to behave. Right? For the wife, similarly, can you see can you have a dominant strategy for the wife? Does the wife have a dominant strategy? No. Because if the wife chooses B, she gets either 4 or 2. If chooses W, she chooses O, then she gets either 1 or 3. So she's better off choosing B only if the husband chooses B, but she's better off choosing O if the husband chooses O. So how does one think? So we don't have a dominant strategy equilibrium. Because we don't have a dominant strategy. So we must think of a new solution concept or a different solution concept. Okay? That leads us to a very powerful solution concept, that of the Nash equilibrium. Okay? What is a Nash equilibrium? A Nash equilibrium is a situation from which nobody has a unilateral incentive to deviate. Mark the words unilateral. As long as you do not deviate, I have no incentive to deviate from that. And as long as I don't deviate, you have no incentive to deviate from that. Right? That is a Nash equilibrium. So it's actually a situation where no player has a unilateral incentive for deviation. Okay? Now, does this game this is a game popularly called the Battle of the Sexes, right? Does it have a Nash equilibrium? It doesn't have a dominant strategy equilibrium. But does it have a situation where nobody has an incentive to unilaterally deviate? Does it? For example, think of BB. So husband and wife both have gone for the boxing. Now as long as the wife continues to play B, Does the husband have an incentive to play O? No. Why? Because his payouts will go from 3 to 2. As long as the husband is choosing B and the wife is choosing B, does the wife have incentive to choose O? No, because the payouts will fall from 4 to 1. So this is a situation where nobody has an incentive to unilaterally deviate. No player has an incentive. That's a Nash equilibrium. Right? This is an example of a Nash equilibrium. Do you have, is that the only Nash equilibrium in this game, or are there other Nash equilibria in this game? Yeah? OO is also a Nash equilibrium? Why is it a Nash equilibrium? Because if both are choosing O, if the husband is choosing O and the wife is choosing O, does the husband have an incentive to choose B? No. Because his payouts will go from 4 to 1. Right? Okay? As long as, and similarly for the wife. So yeah. Now the problem is, which one of them is better? Which one of them is better? You have got two Nash equilibria. Which one of them is better? You can't decide. Right? Because we are not going to make interpersonal comparisons of utility. They, both those two involve two different distributions of utility. Right? So the distributions are different, but we cannot make any a priori judgment on whether we are interested in the welfare of the husband or the welfare of the wife. So if we can't take that, we cannot really decide which one of them is better. Right? But you have two Nash equilibria, and the Nash equilibrium would be one prediction of the game. Right? Nash equilibrium would be one prediction of the game. Is this clear? So difference between a Nash equilibrium and a dominant strategy equilibrium. Review question at this stage is, what is a Nash equilibrium? What is the difference between a Nash equilibrium and a dominant strategy equilibrium? In particular, can you argue that every dominant strategy equilibrium will necessarily be a Nash equilibrium? Will a dominant strategy equilibrium necessarily be a Nash equilibrium? Will a dominant strategy equilibrium always be a Nash equilibrium? What do you guys think? Yes. Why? Because what is the dominant strategy equilibrium? I am playing my dominant strategy. What is my dominant strategy? Which makes me better off compared to any other strategy, irrespective of what you do. You are also playing your dominant strategy. That is, the strategy you choosing already makes you better off compared to any other strategy, irrespective of what you do. So will you have an incentive to deviate unilaterally? No. So therefore, dominant strategy equilibrium will always be a Nash equilibrium. But will the reverse be true? No. This is a counter example, right? Here you cannot have, there is no dominant strategy equilibrium, there is a Nash equilibrium. So the reverse is not true. Right? Reverse is not true. Review question is, create more examples of this kind for yourself. Right? Create more examples of this kind for yourself. Right? Okay? Okay. Now, what are we thinking of? We are thinking of Nash, we think of games with pure strategies. What's a pure strategy? In this case, for example, P1 chooses C or he chooses NC. We are not ruling out a situation where P1 actually says, I am not going to choose C or NC, I am going to toss a coin. And if the coin lands up heads, I am going to choose C. If the coin lands up tails, I am going to choose NC. So he said, I am going to choose C with probability 0.5 and NC with probability 0.5. These are called mixed strategies. Right? They are called mixed strategies.